So Module 13 is all about availability, which is very much connected to the last module, which was on reliability. Availability is going to be directly impacted by how reliable our equipment is. So let's go ahead and jump in and take a look at some of the terminology that we associate with availability. Now, from some of your previous studies with cybersecurity courses, this will be some similar terminology that you've run across before. So, um, upside is repetition will definitely help you to internalize some of that terminology. All right, so operational availability means that the data center can do everything that it's expected to do. And the key indicators that we look for this is total data center uptime and our maximum yearly permissible downtime. So how much annual downtime falls within our agreement parameters, essentially. So we can have different levels of operational ability, and that those um, level operation 0 is going to be that we have more than 400 yearly hours. It means that the data center is less operational and it's able to conduct maintenance during off hours or working hours. A level 1 operational availability means that our annual operational time is more than level 0, right? So it's between 100 and 400 yearly hours. The data center has time to stop, shut down for maintenance. I mean, so far what you've probably heard is not what you've had a picture in your mind for a data center, and that's expected because most data centers aren't going to operate in those low numbers. Level 2 will be 50 to 99 yearly hours. Um, so it still gives us an opportunity to do some maintenance during off hours. Level 3 is 0 to 49 yearly hours. This means it's highly operational and doesn't really spare any time for planned maintenance. Level 4 is what we're mostly familiar with, right? This is a highly operational data center, has no time for pre-scheduled maintenance shutdowns. We're going to have redundancies built in to allow us to get to that level 4 operational wise. All right, so different factors that we can use to calculate operational availability, like weekly hours of operation, annual hours of production, level of operation, permissible maintenance, cease time. These are just terms that we need to familiarize ourselves with, and then we can grade the operational availability. What's our level of downtime risk? And what are the design decisions that can go in to reduce that risk and improve our reliability, right? Remember, reliability and availability are highly connected together. So let's take a look at an SLA, or service level agreement. This is provided when data center space is hired by one of our customers, right? So a customer comes in, says they want to buy some data center space from us. We provide them with a service level agreement. That service level agreement is going to set up the availability and reliability levels that are contractually agreed to between the data center and the customer. So what this does is it holds the data center accountable for providing that agreed upon service. And that availability and reliability level is what the customer is going to expect. And if the data center fails to meet those standards that are set in that SLA, there will be some mechanism for remedy, right? Usually it's going to be fines or reduction in cost, something along those lines. And we usually set that based on the nines of availability. And you heard me talk about that in the last module, and I recommended in the last module video that you go out and take a look at it. So I figured I would bring it in to our discussion here. So this is a typical way that we describe levels of downtime, is in how many nines of availability are available. So in that first row here is 3 nines of availability, which is 99.9%. So that equates out to an annual 525 minutes of downtime per year. Okay, that calculates out to 10 minutes a week it's down. Um, If we go with the 99.99 or 4 levels or 4 nines of availability, that's going to equate to 52 minutes a year, or 1 minute a week of downtime essentially. It always kind of makes me laugh that, I see commercials for, internet service providers talking about how they have 99.9% uptime. And I look at that and say, to the average person, that sounds great. But to somebody that's versed in these availability of nines, that sounds terrible. I don't want 10 minutes of downtime from my ISP a week. I don't even want 1 minute of downtime. So these are things to take into consideration, right? Most data centers are going for this 5 nines. That's usually what their goal is, 5 minutes of downtime per year. And it tells us that, according to Gartner, right, it says that an estimated loss of $300,000 is suffered by a business per hour of downtime related to their data center. So that's very significant, especially if you consider that the data center is likely to have more than one customer, more than one business organization. If you have 10 business organizations, now you're looking at 3 million per hour. All right, a couple of key terms. You've probably seen these before, but it's always good to review them. Are the mean time between failures and the mean time to repair. So the mean time between failures, the MTBF, is it's the time to the start and the end of a failure due to an underlying condition. A lot of the times, if you go and look at the component parts for your computers, the manufacturer will come out and give you an MTBF rating. What that means is that during their design and manufacturing of those parts, they've tested them up to the point of failure, and they've been able to statistically calculate out what that mean time or average time between failure is on that component part. So that's one of the things that you would look at. And the MTTR is mean time to repair. It basically means how long does it take you to fix that failure once it's come into place. Now, if we stop and think about those from a data center perspective, it makes a lot of sense that we want to know how likely is this component part to fail, and then how long will it take us to fix it. All right, so let's take a look at what uptime is. So uptime is the time that your data center is up and running. Again, it tells us that we're looking at 5 nines of availability or higher. And it's going to be an annual calculation. Basically means what time is it up and running or available all year. Whereas downtime is going to be the opposite of that. That's going to be time when the data center is having some type of failure and the data center is not available. So we can classify those in 2 ways. We can have scheduled downtime or unscheduled downtime. Right? Scheduled downtime is pre-planned downtime for maintenance, upgrades, internal testing, that kind of thing, versus unscheduled downtime. So this is one of the things that I would say that my internet service provider is really, really good at, is having scheduled downtime. So I don't know, about once every 2 months or so, I'll get an email. I'll get several emails from them saying, hey, we're going to have an outage at 4 a.m. It shouldn't last any longer than 15 minutes, which then gives you the opportunity as the customer to plan for that. All right, let's take a look at differentiating between availability and reliability. All right, so reliability and availability sometimes get confused, right? Because remember, availability is how often or what percentage of time is that equipment in an operational state. And reliability is the time that it takes for the equipment to achieve its intended functionality. And let's go into those a little bit further, because the initial definitions are a little bit on the vague side. So let's talk about it more specifically from this data center perspective. All right, so with availability, we try to build in some fault tolerances, which means that if some component fails, we're going to put a redundancy in place that's going to increase the opportunity for that to stay up and running. Right, so availability is going to give us a more accurate, a more meaningful measure of the data center's performance compared to reliability. Right, I want to know how often this is available. So most systems have that redundancy built in, which will allow them to have higher availability times. Um, the slide here talks about having a UPS that breaks down because it has an unreliable inverter, but the system doesn't halt because we have an additional backup component. One of the things that I would have probably used something different as an example. The example I think is more simple to understand is most servers, when you purchase them, you can purchase them with what we call a redundant power supply. So if you've ever had a computer apart, right, we have the power supply that takes the AC power or the inlet power in and then converts it over to the proper voltages and everything that the component parts inside the server needs or your computer needs. With a server with a redundant power supply, that primary power supply can fail and the secondary power supply will automatically take over. So the initial power supply can fail, the backup will take over, and now it only is running on one power supply instead of two, but availability stays available, or the system remains available because the secondary system took over for the primary system. All right, reliability is related more to durability or quality of the equipment. One of the ways that I would have you think about the reliability is think about maybe your car. Okay, if you buy a 10-year-old car versus a brand new car, you would expect that the reliability of the new car is going to be much higher than the reliability of the 10-year-old car, right? Because it hasn't worn down. The quality should be better because quality in automotive systems continually improves. All right, so reliability is the probability or the likelihood that some kind of component does its job even under certain operational states or conditions over a given period of time. It's usually going to be expressed or in documentation as a percentage of success divided by the failure of that component over a given period. All right, the example they say is, hey, we've got a UPS with a common inverter failure, which is said to have a low reliability because it doesn't perform as intended. So the reliability percentage will be lower on that because there's a known issue. Okay, so availability, reliability, and maintainability are related. They have a relationship. So availability, again, it's our most critical measure. We've already gone through that a little bit, right? Reliability of the equipment is going to directly affect the availability, and then the maintainability is going to refer to how quickly and easily can we perform repair activities on this equipment to bring it back up to a running state in the event that a failure occurs. So a high maintainability means that you can get in there quickly and fix things, which is going to minimize the downtime. And so a low maintainability score means that repair work is going to be a lot more complex. It's going to take more time and maybe more skill for the repair person to go in and fix it. And again, we're going to think about things like mean time between failures and mean time to repair when we take a look at what our speed and accuracy in doing that relationship of availability. So I thought about taking this slide out, but I left it back in. I left it in because this expresses the nines of availability in downtime per day versus downtime per year. I thought it would be interesting to look at it from that perspective. So with 5 nines, which is the bottom line here, it's less than 1 second per day of downtime with 5 nines of availability. So this is an interesting graphic. I don't think I've ever seen it expressed in terms of downtime per day. So it's pretty interesting. I think if we look at it, right, 99% uptime still gives you 14 minutes of downtime a day. That is significant. All right, some common threats to data centers. We've seen a lot of these before in other modules, so we're going to jump through this rather quickly. Again, power failures, human error, data center level failure, which would mean some larger system in the data center itself went down. And then they're talking about DDoS attacks, right? a DDoS attack, distributed denial of service, significantly will impact a data center because it is the traffic that comes in and out of the data center, which is what makes the data center effective. So with a DDoS attack at any layer can cause a significant problem with the systems. And then we'll talk a bit about brute force attacks and fragile authentication. All right, power failures. Again, why could we have power failure? Grid power fails. We could have another power failure if grid power fails and the batteries don't work. If we don't have fuel for the generators, that can be a problem as well. So yes, we can have power failures. Human errors, again, human error is probably a very common thing that we see, and it can result from multiple different things, right? Accidental activation of safety shutdown, accidental spill of liquids on electronic equipment, improper configuration, probably one of the most likely scenarios. Somebody's improperly configured, maybe a cluster, which causes a workload imbalance, right? Because a cluster is multiple servers acting as one unit. We cluster them together, and the software is going to allocate the workload equally across all of the servers that are in the cluster. And if that is configured incorrectly and you have one, so let's say we have 5 servers, okay, they should each be doing 20% of the load. If you've had a miscalculation or misconfiguration and now one of them is doing 40% of the work and the other 4 are left to do the 60%, that means they're only doing 15% of the work. Means that we're going to wear out that one server faster because it's performing more, it's working a lot harder than the rest of them. All right, natural disasters. Always going to be something that's in the mix. All right, DDoS attacks on DNS servers. So DNS servers are super susceptible to some of these things because DNS, I mean, without DNS, obviously the entire internet breaks down because nobody walks around with the knowledge of every IP address for every web server that they're going to visit every day. DNS does that. So if somebody runs a distributed denial of service attack aimed at your data center's DNS servers, or even something upstream from you, that can cause a significant issue. Now, if we look back at the AWS outage that occurred in the fall of 2025, it wasn't a DDoS attack on DNS, but it was an issue with DNS. And AWS had a DNS problem in one of their Virginia data centers that caused the entire data center to shut down, and it caused some significant outages. I think they were down for about 3 hours. And that was just an accidental misconfiguration that caused that versus an actual attack. We can also have DDoS attacks on your web application. So with those, we can have malicious actors who have maybe a botnet that is continually attacking those web servers over and over and over and over again. Basically what the intent with that is let's get so many requests coming into those web applications that are illegitimate that the legitimate traffic can't get through. And that's really what a DDoS attack's intent is to cause so much of a large volume of traffic that the legitimate traffic can't get through anymore. DDoS attack can also happen on SSL traffic, which is that encrypted link between the web server and the client machine, right? HTTPS uses SSL, or TLS more specifically, to do that. So what we need to do, right, we need to have a means to interrupt and decrypt that SSL traffic, and it can be possible in that event that malicious actors can get in and mess with that, which can then cause our encryption and decryption of that server to have some issues. And the other thing that we can run into with a lot of these is, making sure that we have our certificates in place correctly. All right, brute force attacks is really where we're using a tool to try to run every combination of password that we can think of, and using password predictions and a brute force attack that just continually is hammering on that. And that what they're saying is with it causes fragile authentication because it's a single entry point and it's a single factor of authentication. So how do we do that? How do we solve that? Multi-factor authentication is one way. We could also do some of that authentication services centrally, and you'll have tools in there that can also recognize when a brute force attack is coming into play. All right, so an ADC or an application delivery controller is a tool that can help companies implement security measures at their data center. It's a network component that's typically placed in the data center between the firewall and the application server. Okay, what its job is to look for threats and then cut them off. Right, it's going to look at that data, encrypted data movement through the system. It's going to try to avoid unauthorized admission into the data center applications. So with that ADC, this is our defense in depth strategy that you see in cybersecurity, right? It's after the firewall, which is one layer of defense. Got the ADC, which is another layer of defense. So we layer those defensive strategies on top of one another. And that gets us to the end of Module 13.